Okay, let's continue. I will take a concept resultant of the forces in 2D plane. Yes, there is a question concerning the algebraic geometry course, but this answer is the same with this course also. So if you are sending or submitting those assignments, please only one per one email, because I try to check those assignments every time I have a small break, and if there are many assignments in the same mail, I actually don't have time to waste so much to one email. So I hope there will be only one assignment per one email. Okay, the resultant of the forces in two-dimensional plane.
I can't listen you.
Sorry. You can't hear me.
We can hear you.
Yes, you can hear. Okay. Yes. Yeah. Okay. Thank you. So resultant of the forces in the 2D plane. I will take this kind of example. Let's say we have three forces. I will draw the coordinate axis here first. X-axis and Y-axis, and then I draw the forces there. Let's say we have one force in this direction, another force in this direction, and one force in this direction. So I will have three forces here, and they are all attacked to the origin. And let's say this force has a magnitude 5 kilonewtons, and this has magnitude of 4 kilonewtons, and this has magnitude of, let's say, 4.5 kilonewtons. And then I know the directions or orientation of those forces. I know that this angle here is 65 degrees. Yes. Actually, those people those students which are only watching this video recording, they actually don't know the conversation in the chat box or in the Teams, but we are having a conversation of the online courses, and sometimes there are okay, but actually I have to say that I liked the online teaching those days when we had all those lessons online, but I understand that they are many times very boring for students, even especially when you have to sit whole day and watching only Teams, and it is I can understand that sometimes the concentration is not 100% there. But then, so this was 65 degrees. Let's say this is 31 degrees, and here we have 25 degrees. And now we are calculating the resultant, or the sum of the forces. So we have here three vectors, or three force vectors, and we have to add them. We can't just simply add those numbers there. Of course, we could do that. 5 plus 4 and 4.5, 9 plus the sum would be 13.5. But that is not the correct answer, because these are pointing in the different direction, and the calculation we need to take in the calculation we need to take account what is the direction of those forces. And I will use this here, if I'll not just find some paper. There are many ways to solve this problem. In the course material I have had there one PDF file, which I think I named that resultant of the forces, or something like that. In that example I used a method where I used the angles which were measured from the horizontal plane. So that means that when I had, for example, when I have, for example, this force here, and I know this angle here, 65 degrees, but this is measured from the direction of the vertical plane. So this is 65 degrees, but the angle which this vector forms with the horizontal plane or the x-axis would be 90 minus 65. That will be 25 degrees. So this will be 25 degrees. This is already measured from the horizontal plane, so we don't need to do anything with this. But here this angle is measured from the vertical axis, so we need to use this angle here, which would be, I think, 60. Is this really 65? I was stupid. I made the same. I did not mean to. I should have think twice before I took these angles there. But anyhow, when we are using the angles which are measured from the horizontal plane, then we can make a calculation where we calculate the x component of the resultant force, and in that x component we only use cosines if we know the angles measured from the horizontal plane. And when we are calculating the component of the y component of that force vector, we only use sines of those angles which are measured from the horizontal plane. And if I use that method, I all the time need to know what are the signs of those components. For example, when I am calculating the sum of these forces and the x component of that force vector, that sum vector, I need to know that this vector is pointing to the right hand side of this vertical plane, and these two vectors are pointing to the left hand side of this vertical plane. So in this this x component of this resultant force, we use plus sign for this force and minus signs for these forces, because positive sign we use the right hand side, or the positive x-axis is the direction of the positive x component. So this would get the plus sign, and this would get the minus sign. But when we are calculating the y component, then we compare those forces to the horizontal plane, and in that case these two forces are pointing upwards, and those will get plus sign, and this vector is pointing downwards, so that would get minus sign to the y component of that resultant force. I think I will do that still. First I thought that I wouldn't do that this with the same method as I did in the PDF material there, but I think it is good to get that also here. So method 1. There are many methods how you can solve this problem or calculate the resultant of the forces. I think first method would be so that let's calculate first the angles these force vectors are having with horizontal plane. So I will make this as with the table or some kind of Excel sheet here. So I have force 5 kilonewtons here, 4 kilonewtons here, and 4.5 kilonewtons here. And the angle which we need to calculate is the angle measured from the horizontal plane. Then in this case the 5 kilonewton, this 5 kilonewton force, this angle is 65 degrees, so this angle will be 90 minus 65 degrees. 90 degrees minus 65 degrees, and that is 25 degrees. I hate that my example right now. I will change this a little bit, because I don't like this 25 degrees here. I will put that 28 degrees, if you don't mind. It is stupid to have the same angle in the two same angles with the same example. So I changed that 28 degrees there. This 4 kilonewton force, it already has the angle 31 degrees, so we don't need to calculate anything. And the last vector there, 4.5 kilonewtons, it has the angle 28 degrees, which is measured from the vertical plane, but we need to calculate the angle with the measured from the horizontal plane, so we need again take this subtraction here. 90 minus 28, that will be 62 degrees. So these are angles which we are using in the calculation. Of course, we don't need to do this, but this method helps you to get the answer correct, because with this method you don't need to all the time think if you need to use sine or if you need to use cosine. You only use in the same component, you use the same trigonometric function. It is either sine or cosine, but not both. So now we are having the x component of the resultant, Rx, and I try to see the picture. Maybe we can see that picture there. We have to calculate the x component, and when we are having x component, then the positive sign is to the right, and negative sign is the left hand side is the negative sign. So this is only force which goes to the right from the vertical plane. So this will be plus. So we will get plus 5 kilonewtons times cosine of that angle we measured there of 25 degrees. I only need to remember that in x component I use cosine. And this is because we have measured the angles from the horizontal plane. So when I take the next component, I only check what is the direction. This 4 kilonewtons goes to the left hand side of this from this vertical plane, so I will get minus sign there, and the magnitude of that force is 4 kilonewtons and the angle is 31 degrees, so I only need to write this cosine here. And the last one, this 4.5 kilonewtons, it also goes to the left hand side from this vertical plane, so that will also be minus, and the magnitude is 4.5 kilonewtons and the angle is 62 degrees, so we will get it like that. So now we need to calculate the value of this vector. Oh, sorry, this is vector. This is not vector, this is component of that vector. Let's see if we can get it here. I hate this document camera. This is so poor. As I told, at my home, when we had this COVID time and online courses, or all courses were online courses, I decided to buy myself a own document camera, and that value of that camera is way better than this, which I have got from my university. So here I have that calculation, and let's see what we get to the answer. Minus 1 point, etc. Minus 1.00975, etc. And then we have the kilonewton to the as a unit. This means that the sum force of these three forces we have this in this picture is that kind of vector that has a horizontal component about approximately 1 1 kilonewton, and it is negative. That means that the sum force or resultant force is some kind of force that goes to the left hand side from this vertical plane, because this is minus. And now we have to calculate with the same method the y component of this resultant. Y component of the resultant. In Finnish, when I write this sentence in Finnish, you actually can understand what I mean, because in Finnish the order of the words is different than in English, but we would say resultantin y-komponentti. The y component of the resultant, this n ending in the word resultantti, that is genitive form. Y component of the resultant. So now we are calculating Ry, and let's take that picture again. And now when we are calculating the y component, we use the horizontal plane there and see that these two forces here, they are pointing upwards from the horizontal plane, and this one force there is pointing downwards. So in this component we use plus signs for these forces and minus sign for this force. So we only need to check these signs, which signs we use in this y component, but then these sentences are, or expressions there, are almost exactly the same. The only difference is that we don't use cosine but sine there. So this method is very easy. We only need to check those signs, and then we need to change the sign in the place of cosine. So now this 5 kilonewtons, it goes to the upwards, so it will have plus sign 5 kilonewtons times sine 25 degrees. So this only the sign we need to check, but this part is the exactly same, with that difference that we need to change this cosine to sine. And then we have this 4 kilonewtons. It also goes upwards from the horizontal plane, so it will be also plus sine, and then we get sine 31. And the last one, it is the only force here which is pointing downwards, so it will be minus 4.5 kilonewtons times sine 62 degrees. And remember that all these angles are measured from the horizontal plane. And let's see what we will get. Uh, 0.1999, etc. I will write the plus sign here because it is a positive number. I need to be sure careful with those signs that I will have those correctly. 0.19, how many nines there? 3. 79, etc. kilonewtons. So now we have calculated those components of those of that resultant force. Rx is about approximately -1, and this Ry or Y component is approximately 0.2 kilonewtons. And if we draw the picture of this force, let's draw a picture of this resultant force. I will take another paper. These components were, I will write them again here. Rx is approximately minus 1.0097 kilonewtons, and Ry is approximately plus I don't want to round that. I only rounded by cutting. I didn't check those last decimals if they are rounded correctly. But if I am drawing a picture of this, I will use a scale that 10 centimeters equals 1 kilonewton. So this Rx is approximately -1, so in my scale that will be approximately 10 centimeters. And I will draw a point here, and then this Rx is -1, so it goes approximately 10 centimeters to the left hand side, so that will be Rx. And then this Ry is approximately 0.2 kilonewtons, so that will go. Again I draw a bad drawing. Let's draw a better drawing. So here is my starting point, and again I am doing. Now I think I can draw that well. So this is the Rx. This is approximately -1.00 kilonewtons, and it goes to the left, and then the other force is approximately 0.2 kilonewtons, so in my scale it will be approximately 2 centimeters, so it will go like that. This is Ry, this is plus 0.1999, and the resultant force is the we can think that this is a hypotenuse of this triangle we are drawing here, so this will be the resultant force, and this is R. And we are having here rectangular triangle or right angle triangle there, and as you see, we can calculate the length of that R vector or that resultant vector with the help of Pythagoras. So the magnitude of resultant R, let's draw that vector line there, that will be Pythagoras and the unit is kilonewton. And let's see what we will get. Those are so nasty numbers that I will pick the correct values from this calculator. I don't need to use that rounding. So if you are using these values, you will get a little bit different result, but I will take the exact values there, so I don't need to type them again. So this is a Pythagoras, and we get the answer 1.02936, etc. kilonewtons. I draw that picture in approximate scale, and if I had this scale that 10 centimeters is approximately, or it means in this picture 10 centimeters means 1 kilonewton. So if I measure this length of this vector from my ruler, I get an answer that if you check that value there, you can see this approximately 10.3. So if we divide that by 10, we get the length of that vector. It would be about 1.03. And actually, if you round this to 2 decimals, you can see that it is exactly the same that I got from this ruler here. And then the direction. We need to know also the direction. As you probably remember, when we are using those vectors, we need to know magnitude, unit, and direction. Now we know magnitude and unit, but the direction we need to calculate. From this picture we have here, and I suggest always to draw this picture, because you can't find the direction correctly, or you can't be sure of the direction if you don't draw that picture. We can calculate this angle here. Let's call that, for example, alpha here. The angle alpha of that triangle we know these sides of that the cathets of the right angle triangle. Then we can calculate the angle with the help of tangent. So we know that tangent alpha equals this divided by this. And let's not use those signs there. We only use those positive or absolute values of the lengths of that, because we are having this triangle. We don't get negative values for the sides of the triangle, so that's why we use only the positive numbers here. So we know tangent alpha is 0.1999 kilonewton divided by 1.0097 kilonewton. Again, I will take those exact values from my calculator. So tangent of that alpha is this, so this alpha will be inverse tangent of that division. And we can cancel those units, kilonewtons, away. So let's see what we will get. Inverse tangent there, and then I pick that and divide by that. I will, oh sorry, I made a mistake. I have to be more careful. Control C and Control V, and I take that. There is now that minus sign there, so I will take that away, not to make any complexities there. So I get, or my calculator gets 11.2 degrees approximately. 11.2023 degrees. Let's check that from my picture. I have this possibility, and if I measure the angle of the magnitude of that angle, well, in my drawing it is some angle between 10 and 11 degrees, approximately 11 degrees, and as you see, if we round this to whole number, we get that 11 degrees. These drawings are very good. You many times can check with the drawing if you draw that picture with accurate enough. But this is not yet the direction, because this only tells us that the vector this is an angle which that vector has with horizontal plane here. But the direction angle which we need to calculate is always an angle measured from positive x-axis. So when we are having here the origin, and I will draw here the positive x-axis here, y-axis goes here, and here is origin. And the angle we need to calculate, of course we need this angle, but this is not yet the direction angle of that resultant. The direction angle of the resultant starts from the positive x-axis and goes counterclockwise to the resultant vector. And this will be direction angle, or angle of direction. I won't use alpha there, I will take theta. There you may choose the name of this angle freely. It is not defined by any how. You may choose what name you want to take, but maybe this theta is quite good. So in this case, the direction angle can be calculated when you know that this angle, if you start from positive x-axis and end up to negative x-axis, this will be 180 degrees, and then you have this alpha here. Then the direction angle you get by taking 180 degrees and taking away this 11 degrees there. So the direction angle direction angle of the resultant is measured counterclockwise from the positive x-axis. So now this theta equals 180 degrees minus 11.20323 degrees. And let's check what is that angle. $168 degrees. Yes, I will. Yes, I had a question in the chat box. I will answer that very soon. So I will 76 degrees. Of course, you could measure that also with the help of this. I will check that. Now 0 degrees is here, and you counterclockwise go to the direction of the resultant force. And if you had, now you can see from this picture it is approximately 169 degrees the angle, and as you see we get the accurate if we round this angle to the whole number, we get the exactly the same angle as we got from the measuring from the picture. The method to express the answer, or the express what is the resultant force of these three forces. Resultant force of those three forces is, we may say it like this, or write the answer like this. First we take the magnitude here. Let's round it a little bit. Approximately 1.029 kilonewtons, and the angle or the direction angle of that force is that angle, and if I round that to 2 decimal places, it would be 168.80 degrees. So this would be our final answer. This tells us exactly what is the resultant force. It has a magnitude of about 1 kilonewton, and it points to this angle, to this direction, which you can measure from the positive x-axis. But I point that this picture is very important when you are solving the direction angle, and also when you are calculating the magnitude, because you can from the picture measure the answer if that goes correctly. But there was a question about that Rx component here, how I calculated that. I had, sorry, where is the picture? I had this picture here. I first calculated those angles between horizontal plane and force vector. So these were all calculated from the horizontal plane. This was actually given in the problem, but these two angles needed to be calculated. And when I had these angles there, then I calculated the x component of the resultant by using cosines of those angles and the magnitude of those forces. And these signs here, that depends which direction those forces are pointing when you are comparing the direction to the vertical plane. And this vertical plane, you can see that only this force points to the right from this vertical plane, and that's why it has plus sign here. But these two forces here points to the left, and that's why these forces have minus sign here. And then I used calculator to get the value of this. And the y component with the same method, but we take the horizontal plane there and like this, and like this, and we have horizontal plane, and now we are comparing it to this horizontal plane, and these two forces are pointing upwards, and that's why those forces will get plus sign, and this is the only one which points downwards from the horizontal plane, and that's why it gets minus sign. And then same angles, but we change those cosines to sines. Well, this method is very good method. I think I mostly use this method when I calculate my if I have some statics course or course concerning vectors. I mostly use this method. But there is also, I don't know if it is better method, but one method which I take with you also. I had this method 1, but the method 2 is a method which we may use, which we may do with the help of tables also only. So method 2 is that let's calculate the direction angles of force vectors. And I will use table method here. This method is good method if you are using, for example, Excel, because it helps you a lot. So I have here force 5 kilonewton, 4 kilonewton, and 4.5 kilonewton. And then we need to calculate the direction angles of these vectors. So the direction angle is always measured from the positive x-axis. So for this 5 kilonewton force, the direction angle is this angle, and so it is exactly the same angle as we used in the previous example, 25 degrees. The next one, this 4 kilonewton, we don't use 31 degrees but the direction angle, so that means the angle which starts from the x-axis to the and ends up to the direction of that force. So that will be 180 minus 31. And the last direction angle will be that angle which starts from positive x-axis and ends to the force vector 4.5 degrees. And we know that this is 28 degrees, and we know that these are all quadrants are 90 degrees. So this is 90, this is 180, and the last one is this negative x-axis is 270 degrees. And if we take away 28 degrees, then we will get the direction angle of this 4.5 degrees. So if we calculate direction angles, then in this first force, the direction angle is the same as we earlier had, 25 degrees. The second force, the direction angle, we take first 180 degrees and then take away the 31 degrees. So we will have you probably see that I took a calculator. I could not make a miracle by calculating by head. 149 degrees, and then this last force here that's pointing there, and as we saw that this negative y-axis equals that the direction angle of the negative y-axis is 270 degrees, and if we take away 28 degrees we will get the direction angle of this 4.5 degrees, 4.5 kilonewtons. So 270 minus 28 degrees, so we get 242 degrees. And what use do we have with these angles? Now we can manage the problem with the much easier way than earlier, because earlier we had to think about those signs. Are those plus or are those minus? But when we are using these direction angles, we don't need to mind of signs anymore. We only use this method, but use direction angles there. So this Rx or x components we get by 5 kilonewton times cosine 25. So there is no sign there. The same with this, 4 kilonewtons times cosine 149 degrees, and the last one 4.5 kilonewtons times cosine 242 degrees. If you are using Excel here, so you only need to write those magnitudes of those forces and to write those angles there, and then you just pick those values from this Excel sheet, and then you can calculate the component. Of course, you need to use Excel uses radians angles. You need to change those angles to the radians before you can use Excel. But there is a command in Excel, command named radians, that makes the changing from degrees to the radians. The same with y component, exactly the same, but you just change sign there, sinus. So we will get 5 kilonewtons times sine 25, 4 kilonewtons times sine 149, and 4.5 kilonewton times sine 242. And then if you calculate the sum there, you should get the same result as we got earlier. Let's check. 5 times cosine 25 plus 4 times cosine 149 plus 4.5 times cosine 242. So as you see, there are no minus signs anywhere. As you see, we get the exactly same answer as we got earlier. So this will be minus 1.00975 kilonewtons. And with the calculator I can change those cosines to sines quite easy. Well, there are some problems, but I don't need to write the expression totally again. So now we have the same as above, but we have signs there. As you see, this is the same result as we got from this earlier example. And this continues with the same way as earlier. Okay, so this is the I think today's lessons are here. I think you have possibility to calculate those assignments, and those assignments from 5 to 8, those are assignments. Those assignments 5, 6 and 7 are assignments where you use this. You have to calculate the resultant force, and then the assignment of 8 is the assignments where you have to create the force vector. So you will get the practice for these concepts we had in this today's lessons. But I think it's time to end today these lessons. I hope you can practice these things right now, but I will be here if you need to help, or you have any questions to ask. You may use WhatsApp or email. I will sit here. But I will end recording now, and I will give you time to practice right now. Thank you for today's lessons.